Hello, let's continue our Sudoku adventure with Mysterious Monolith by MicroStudy. So we have normal 6x6 Sudoku rules in every row, every column, and every 2x3 box. We are placing the digits 1 to 6 exactly once each. In addition to that, we have Kropke dots. So black dots separate digits that are a 1 to 2 ratio. So a cleaner way to say that is 1 is exactly double the other. So if this is a 2, this could be a 1, or it could be because 2 is double 1, or it could be a 4 because 4 is double 2. So the order doesn't matter, just one has to be double the other. And then white dots separate consecutive digits, so a difference of 1. So if this is a 2, this could be a 1, or it could be a 3. Not all the dots are necessarily given, so I could have 2, 3 here, there's not a white dot, that's fine. I could have 2, 4 here, there's not a black dot, that's fine. It's positive information only. In addition to that, these two columns are marked in red to remind us that they are indexing. So what does that mean? So digits in column 1 tell you where the 1 is in that same row. So let's say this was a 3. This says, hey, go to the third column, that's where the 1 is. If this is a 5, it says go to the fifth column, that's where the 1 is. So hopefully that's clear. And then this column tells you where the 6 is. So if there's a 2 here, you go to the second column, there's a 6 there. Now you're always counting columns 1 through 6 this way. It's not, 2 doesn't mean 6 is here, 2 means 6 is here. All right. And so those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I am going to get started right now. All right, we do have 2 black dots in this column. So one of these has to be 3, 6 because you have 1, 2, 2, 4, and 3, 6 that can go across a black dot. And 1, 2, and 2, 4 both share the 2. Not sure if I can use that piece of information yet. So there is one thing that we can think about, which is these tell us where the 1 goes in the same row. So one of these will be 1, 2, 3, pointing at, we don't know which one, but let's say it's this one, right? One of these will be from 1, 2, 3, pointing at the 1 up here, which means the other one will be 4, 5, 6, pointing at the 1 over here, or the other way around. But what we can't do is do, say, 1, 2 across this black dot, because if we do that, that's saying there's a 1 here and a 1 here, and you can't repeat 1s in the box. So we're going to have 1 low from 1, 2, 3, and 1 high from 4, 5, 6. So this is either going to be a 2, 4 or a 3, 6. You can't actually put a 1, 2 across here. Here is fine. A 1, 2 across here would be fine. But within the same box, we wouldn't be able to. Similar, that actually gives away what this is, right? Because how do we have 2 consecutive digits that don't disrupt the boxes, right? They have to be here. So that's going to be a 3, 4 pair. And then that does mean that the 6s are somewhere in here. There's actually 2 6s. They're either here or here. And so that means that this can't involve a 6. So this actually is 2, 4, which means we have a 1 here and we have a 1 here joining the 6. So this is actually a 1, 6 pair. So we can get rid of the corner marks there. The 1 would go with a 2, which isn't possible because the 2, 4 pair. So we are actually get 6 and 3. That's a 1. So now that we found the 1, that we can place the 4 here because it is in the 4th spot. And this is 2 and 1 like that. That gives us the 3 and the 4. And the 4 does point here for the 6. And the 3 points here for the 6. So this is a 5, and then these are done as well. This is a 2, and this is a 5. Nice. We're 1/3 done. Not usually how you solve puzzles, but there we go. We got the 2 top rows done. So what do we want to do with this? We know this is 3, 6 now. And so that means that we either have a 1 here and a 1 here, or we have a 1 here and a 1 here. Either way, there's a 1 on this black dot, right? Wherever the 6 is here, it puts a 1 over here. So this has to be a 1, 2. So that means that there's a 6 here somewhere. So the 6s are actually done for both of these columns. We can fill that this is a 1, 5 pair. That might be helpful. So one of these 1s points at itself. The other one points at the 1 in this column, which is here. We can fill this pair. This is a 5, 6 pair. So one of these 6s points at itself, the other points at the 6. So this is actually a 1, 6 pair because we're going to have a 1 in the 5th column and we're going to have a 6 in the 5th column in these same places. So this is a 1, 6 pair. And then this is going to be 3, 4 to finish off the column. I'm wondering about this white dot. It can't be 1, 2 because that breaks this cell. If this was 1, 2, we'd have too many 1, 2s in the row. 2, 3. I don't know why, but 2, 3 feels off to me for some reason. But let's fill that. It could be, oh, sorry, the other way around. It could be 2, 3 this way because we have this 3. 3, 4 is not possible because of this cell. Oh, I know why 2, 3 is bad. Okay. We have an X-wing on 3s here. So none of these can be 3, right? We know there's a 3 here and there's a 3 here. That's the only 3s we get for these 2 rows. So there cannot be a 3 in here. So this cannot be 2, 3. It can't be 3, 4. So this is, and neither of them can be 6. So this actually has to be 4, 5. It's the only option. 1, 2 breaks this. 2, 3, and 3, 4 involve a 3. And then 5, 6 involves a 6. So that 4, 5 pair does give us this 3 and this 4. Gives us this 6 and this 3. 6 gives this 1 and this 2. 3 actually places a 1 here. That gives us this 5 and the 1. 5 places a 1 here. This is a 6, which places a 5 here and a 6. That's 4 and 5. And the rest should just fall into place, I assume. So down here and here are the same digit. Oh, and what is it? It's a 2. And then up here we need a 3 and a 4, which we can place. This 6 needs to go here. This 5 needs to go here. This finishes the box with a 3. And then over here we need a 2 and a 4, which go like that. Very nice. Wow. Cool puzzle, MicroStudy. Nice use of the indexing constraint there. Quite enjoyed it. I liked how this white dot basically perfectly forced the rest of the puzzle to finish. So a very nice placement there, and not too hard to figure out that, oh, there's one white dot left. Let's look at what it can be. So very cool. Thank you again. And of course, if you enjoyed this, then why not leave a like, subscribe, and a kind comment below.